Hi, my name is Romain Nith, and I'm really excited today to talk about my latest project called SplitBody, done in collaboration with Yunho and my advisor Pedro Lopes at the University of Chicago. Let's take a look at this person trying to multitask. She's trying to, on one side, write an essay, and on the other side, cooking caramel. For those who don't know, caramel consists of melting sugar and stirring in a pot. And if you stop stirring for a little bit, the caramel has a chance to burn. Let's see what happens when she's trying to do those two tasks at the same time. She gets overwhelmed and almost burns the caramel. So what if we add muscle stimulation? Here, she's wearing a device on her left arm that can generate a small electrical impulse into her muscles, which creates an involuntary muscle contraction. This is muscle stimulation. She turns on the muscle stimulator, and the muscle stimulation is going to create this stirring motion for her automatically through her muscles. We're doing something very interesting here. We are separating the body in two. On one side, the muscle stimulation is automating the gesture, the stirring gesture, we call it the split body. And on the other side is being completely fully controlled by the user. So now that the steering motion is being automated, she can actually focus on writing the essay all by herself. She finishes the caramel, tries it, and it tastes delicious. The caramel that you see here on the screen, we actually tried it in the lab here, and it tasted just like caramel. Let's take a step back and look at existing work on electrical muscle stimulation. Muscle stimulation can help assist person at playing an instrument. For example, it can show you how to position your finger and press on the fretboard of a guitar. It can also be used to display information, such as spelling American Sign Language. And finally, it can also be used to augment the user in sports. For instance, it can show you how to play golf or even speed up your reaction time. All these systems have one thing in common. They're using muscle stimulation for foreground tasks that the user is already attending to. For instance, if I'm playing the guitar, the muscle stimulation is helping me play the guitar. But in SplitBody, we're doing something different. We're working on two different tasks at the same time, one being assisted by muscle stimulation. So it begs a question, will EMS help me multitask better? Well, let's investigate. We conducted a user study where we asked participants to perform two tasks at the same time. The first one is a movement task, where they have to move their wrist in a specific pattern. The pattern goes as follows: up, down, left, right, and then we reverse the order. Down, up, right, left. And they have to do this while doing the other task, which is a cognitive task. Here we're doing a two-back. Basically, the participants are being shown letters on the screen, and they have to say like if the current letter is the same one as they saw 2 letters ago. And we do this in two conditions. The first one is automation by muscle stimulation, which is the split body condition. And it's exactly what's happening right now. My wrist is being moved by the muscle stimulation, and I'm still being able to give my talk. I'm going to stop it now. And I'm going to try to attempt to do the pattern by myself while still continuing to present. So, coming back to the talk, now I need to show, well, this is really hard. I'm going to stop for a bit. So we're doing a second condition where they have to do it by themselves. And as you can see here, I was struggling. And we saw that the split body condition actually increased the task performance almost by double. So this means both movement task and the cognitive task increased. This kind of makes sense for the movement task because the muscle stimulation was already automating my wrist, and we saw an increase of 2.5 times. But what is interesting is that the participants were able to focus on the cognitive task while leaving the automation for the EMS, the muscle stimulation. And we saw exactly that. We saw an improvement of about 1.3 times on the cognitive task. We also asked participants to rate the perceived mental workload using the NASA TLX, the task load index. And we saw that SplitBody did, in fact, decrease the perceived workload by actually 1.5 times. And the 6 parameters within the NASA TLX all decrease as well. More specifically, the mental demand and the physical demand decreased by 1.4 and 2.3 times. So we showed that SplitBody can actually decrease the mental workload and increase the performance of multitasking. So what can we do with it? In this application, a user is trying to draw a boat. So he starts by drawing the sail, and now he hits a switch, allowing SplitBody to help him color the sail while he continues drawing the rest of the boat. He switches the colors and does the same thing with the red pen. We actually had a lot of fun doing this at our lab, and this is actually the drawings that one of my lab mates came up with. So on the left side, I asked him to draw the same thing, so the boat, and on the right side, I asked him to be creative, use SplitBody however they wanted it to. SplitBody can also be used for playing 2 different instruments at the same time. Here, Aki is playing the drum and the synth. He presses on the foot switch, and the drum pad is being automated by SplitBody, while the right hand side is being user controlled, so he's playing the synth by himself. And what is interesting here is the roles can be flipped. So here he presses the foot switch, and now SplitBody is playing the synth for him while he is drumming with his left hand. SplitBody can also be used to play a more complex instrument such as drumming that requires multi-limbs synchronization. Hunter, a high schooler working in our lab, here is discovering a new musical sheet for the first time on the drums. He's not very proficient with drumming, so he is trying to hit the hi-hat, integrates the kick at the same time, and then tries to play the snare, but it's a mess. There's too much information there. So what happens when you use SplitBody? Here, SplitBody is going to start by automating the hi-hat according to the musical sheet, adding the kick drum, and now he can integrate the snare by himself and follow along the music sheet. He gets comfortable and starts to improvise as well. So here the hi-hat and the kick is being completely automated. So, in conclusion, today we showed a concept called SplitBody, where we split the body in half, with one part being automated by muscle stimulation and the other part being user controlled. This allows you to multitask better. But there are other means outside muscle stimulation that also help assist task. For instance, exoskeletons, robotic limbs, or even tools. But they haven't really tackled this question of reducing mental effort. I'm sure they do reduce the mental effort to some extent, but if they do, how do the users benefit from it? And this is exactly what we tackled in this paper. The key difference between the electromechanical systems that are external and muscle stimulation is that muscle stimulation is moving your body through your muscles. The difference is really important because by doing so, you are involved in the task at hand. Whereas a robotic arm, for instance, will be doing the task for you, completely decoupling you away from that task. And this opens up to a lot of exciting questions for us. Like, how much benefit do the users get by automating their body? For example, if you're cooking with muscle stimulation, can you feel the resistance as you're stirring through the caramel as it's thickened up? If you're playing the drums, can you become a better drummer? And if you're drawing, you're probably not going to draw better, but can it open up to a new creative outlet? And this is important because in an age where everybody's trying to automate with external tools, we're trying to do so with internal tools with your body and see what are the benefits of doing so. Thank you for listening, and please check out the paper for more details.